Hey math kids, today we're going to talk about independent events, and yeah, let's get started. So once again, I have a recreation of some of the homework problems that you'll come across. However, these are not the same problems, so make sure you're doing the ones on your homework sheet, not the ones in this video when you turn in your assignment. So the first thing is just a general idea of what independent events are. Independent events are two events that do not affect each other. So a really common scenario is if you roll a dice and you flip a coin, if you get a 6 on the dice, that doesn't change the probability of getting tails on the coin, right? So if we roll and we're trying to get a 6 on a standard dice, we have a 1 out of 6 chance. If we're trying to get tails on a coin, we have a 1/2 chance. So if we do those separately, those are their probabilities. Now, if we do them together, they still have the same individual probabilities. Now, if we want to know the probability that they'll both happen, we can see that there's a formula up here. And if they are truly independent, the probability that both of them happen, or the intersection, is the same as just multiplying their probabilities together. So if we multiply these together, the probability of getting 6 and tails is going to be 1 over 12. Just 1 times 1 is 1, 6 times 2 is 12. So that's the basic idea of all of this. So now, let's put this into practice. So we want to know which events are independent. So right here we're looking at A and B, and if we multiply them together and get 1 out of 15, then we're going to say that they're independent um, of each other. If not, then we're going to say they're dependent. So if we take 1/5 and we multiply it by 1/3, 1 times 1 is 1, 5 times 3 is 15, and so A and B are independent. Okay, now if we look at A and C, so we're going to look at A and C. If we do 1 times 1, we get 1, 5 times 4, we get 20. So for this to be independent, it should have been 1 over 20, but it's not. So we're going to say this one is dependent. Okay? And the last one, we're looking at B and C. So B and C. If we do 1 times 1, we get 1. 3 times 4, we get 12. That's what we have right here. So we're going to say that those are independent events. Okay? Now we're going to look at a story problem. This one says, Jamantha wants to know if eating candy and slapping high fives are independent events. 10% of her friends eat candy. So we're going to say candy, 10%. And then we'll just say fives is 30%. And then both is 3%. Okay, so we're going to use this relationship up here. What we need to do is transform these into decimals. So we just move it twice. So this is 0.1, this is 0.3, and this is 0.03. 0.1, 0.3. Okay, so what we're going to do, this is like our event A. This is the probability of event B. And this is like the probability of A intersect B. So if we do 0.1 times 0.3, if we plug that into a calculator, it's going to give us 0.03. And since this is equal to this, we say that those are independent. And it says to justify our answer, justification is using that. Okay, we have one more. Let me get rid of this. Okay, so we're looking at number 4 right now. It says math. Yes, someone named their kid Math. Tosses a coin and spins a number spinner with 6 numbers on it, labeled 1 through 6. So we could also think of it just like a dice, essentially. What is the probability that the coin will land tails up and the spinner will land on a 4? Well, so we want to find the individual probabilities. So tails is 1/2. The 4 is going to be 1 out of 6 because 4, there's only one spot that has a 4. And we're going to assume that it's evenly spaced and all of that is fair. Okay. Now, are these events independent? Now, if we flip a coin, it's not going to change how the spinner spins. And if we spin the spinner, it's not going to change how the coin flips. So it's reasonable to believe that these are independent. And since they're independent, if we want to find the probability of both things occurring, we just multiply them together. So 1 times 1 is 1, 2 times 6 is 12, and so the probability of both of those happening is 1 out of 12. If you need additional help, please come to Math Lab. Until then, calculator.